Good morning, everybody. I'm Monica Segan, and I'm faculty at Department of Engineering, Physics, and Technology in Bronx Community College. I teach physics, astronomy, and sustainability. And 3 years back, I got my training in online course development at BCC. It was a year-long training. And as a result of that training, I created an online course, which was really good experience and also brought some results in front of me, which made me think maybe we need to do something more along those lines, where we were able to meet the needs of some of the students and at the same time inspire many students to think outside the box and not just stick to the lecture teaching format and consider other approaches to learning. So this is my work on online learning with respect to astronomy course. And as time progresses, I hope to introduce this in other subjects also, but for now it's in astronomy. So this will be the general outline of my talk, where I'll share with you what was my motivation to begin with that, and what is the methodology that I'm using in my class, which is not lecture-based format, some of the results that I would like to discuss and conclude, and where are we heading with that experience that we have and how we can make it better. So online learning is not something new, as you may be aware, and it's something that we have seen. This online course is being taken by students, that number is increasing, and according to Allen and Seaman, it's at all-time high of 32%. Especially with respect to community colleges, we are noticing increase in online courses being available in the past decade. And after teaching that course, I can really see what this publication is trying to say, that it really gives a benefit to students to study something at their own time and not running something that they can make use of it according to their schedule and be at the same time commit to the other things they have already committed to. Also, it's an approach which basically helps us develop self-learning among students, because they are the drivers. We are the navigators for them. And that's what we eventually want, our students to step up and do things and take responsibility of their work. So this approach has helped students, and it has also helped instructors in many ways, which I would love to share with you. So my motivation was stemming from the fact that what I was doing in my regular class, I do the traditional classroom approach also, and I do online also. So I have both the perspective. So every time I was doing the lecture-based format, I felt the lecture-based methodology was becoming redundant. It was very hard to engage students for 2 hours and 50 minutes of class time, even though we would give breaks. And I needed to think something, what different can we do besides me lecturing students with PowerPoints? So this is where I was thinking how I can bring technology and tools into the class. So instead of me telling students, let students be in charge of their learning and let students play with the technology and see what if their outcome is different. And this is one of the works that has inspired me also, that by Carl Wieman. He's a Nobel laureate 2001 in physics, and his latest book actually is highlighting that the way technology has become part and parcel of our lives, how this is changing how teaching should be done in higher education. So I applied my approach in astronomy, but astronomy is not the only subject. We have results of this online learning in addition to regular learning applied in psychology, applied in social statistics, even part-time master's degree students have got an experience of that. And there are many areas where we can see the benefit of online learning, which is no less than the benefit student would get in a regular classroom. It's just how a student connects with that. So it's very student-centered. If there are students who are committed, they're driven, all we have to do is navigate them every week for the whole semester, and then they can get to the final destination point. This is where online learning is very helpful. So this is the course I'm teaching. I have been teaching in the last 3 years, and this semester also I'm teaching this Astronomy 111 Stellar Astronomy. The basic guideline is we are trying to understand what's happening in the stars and galaxy, and trying to understand the evolution of stars, how stars are born, how they evolve with time, and finally how they die, all that interstellar medium stuff. So this is what I first of all have to clarify my students, and this is something very interesting. Most of them come with that assumption that I'm here to tell them about their zodiac signs, which I'm not. So in the very beginning, I have to clarify that you're going to be learning science. You're not learning your future, but I can tell your future would be bright if you apply the scientific approach to understand stars. So I have to clarify that this is not astrology. So basically, if we were to look at what are the major differences between these two branches, astronomy is total scientific study, which is based on the study of celestial objects and universe as a whole. So it's a pure science we're looking here in comparison to astrology. But astrology, we call it pseudoscience because we're trying to see how the position of stars is going to influence the lives of human beings. So students think, oh, astrologers do mathematical calculations too, so isn't that science? Well, yes, that part is science. But the part after that, how it's going to influence your life, we don't know. That's very subjective. So that's why it's a pseudoscience. Okay. So when I'm doing my courses, and this is uniform across all the courses I do, there are 3 different objectives that I'm trying to work in my teaching methodology, and I want to assess students at the end of it if that is integrating very well in my teaching and their learning process. Mathematical methods, if you think about it, we live in the world of numbers. Anywhere you think about the phone we use, 32 gigabytes, 32 is a number. Taxes we pay, that's all numbers. So numbers are very much part and parcel of our life. So I want students to be able to understand if it's a big number, how does it look like? If it's a small number, how does it look like? To make a sense of increasing, decreasing, range, all that. Then I want them to think like a scientist. I don't want them to take the information just on the face value of it. So whenever I'm teaching a concept, I'm asking them to observe. Observe what is this image telling you. Just see if you can make some kind of hypothesis. Just see if it's going to hold true. So I want to encourage that in my teaching in different lesson plans. And also when I'm providing them some writing, then I'm keen on them analyzing a piece of information or reason out that piece of information rather than just cram the information. So, and at the end of it, I want to check if those skills, I want to assess if those skills have come to the fruition that I would like to see. So major, in few points, what is my methodology? Since astronomy is a subject which we are all very curious about, most of us are very curious about, because we're curious about where we came from. That curiosity is holding well among students also. And there's a lot of news every day related to astronomy, whether it's a full moon, or it's a new moon, or it's a red moon, or a Cassini spacecraft landing on Saturn. So there's a news every day in the newspaper, on radio, on internet. So what I try to do, I pick up very often astronomy news of the day. The most common one that I can think of right now is every semester there is a change of season. So, okay, today is vernal equinox. Welcome to spring. So that's my introduction, that news related to what's happening around you. Astro tours, I cannot be lecturing them all the time, neither I intend to lecture them. I want them to be engaged. So there is some technology-oriented stuff from the Norton Publishers, which is the book that we're using, where they have this kind of resource available to them on the Blackboard system that we use. So if I'm not there, the lecture is there in the form of some digital format, and if we have time, I would love to show that to you. Astronomy is a subject. Even we, as a faculty, learn new language, new vocabulary many times. So I create a special dictionary for them, so they can go back to the words. Like many of them think light year is a unit of time, because there's a year with that, but it's a unit of distance. So I have that definition ready, and I provide them that dictionary, and we build it up all through the semester. Then there are simulations. We all have this craving, even I have at times, of pressing the buttons. So simulation satiates that craving where we can play with the simulation. Let's try to move moon in this moon at this time period and see, do we see half moon, do we see crescent shaped moon? So there are simulations, which again, if you time permit, I would love to show it to you. So there are buttons they need to play with like a video game. Nebraska simulation, that's popular in astronomy. And then we're using online system, which is called SmartWork class assignments, where the assignments I have created for students for traditional classroom approach, I have 50 minutes that I put them on computer. We go to computer lab and they attempt those assignments in the class. For online students, we have homework assignment and process of science assignments, which they need to attempt. The advantage of this is it gives me an opportunity in limited time period to provide opportunity to students to do multiple choice, to do numerical reasoning, to do calculation, to do fill in the blanks, so different options, and instantaneously there's assessment for student, how well a student has performed, how much time a student took. All that assessment is so instantaneous, the student can also see where the student stands, and I can see the student report. So that's where this has been a very useful tool for us. So this is one example which I was talking to you, where I would host, welcome, it's autumnal equinox. As an astronomy student, now you have read about it in chapter 2, what this is. Can you make sense of it now? Today is September 22nd. So just encouraging them, to think a little bit beyond just reading the textbook or a lesson. One of the other approach I have is to build mathematical skills. So I want students to be able to see, can they arrange from smallest to largest? If I will give them 10, 17, 99, that's easy. But when I start giving this fraction, this exponents, negative, positive, there's a little pause at times, especially for students who come after a gap of years in education. So I want them to be able to understand if there's a negative in the power here, that means it's a very small number. If there's a positive power, that means it's a very big number. So sometimes they are not looking here, they're looking here, and then they make the wrong judgment about it. So it's very important to make sense of it. Also, we use this kind of vocabulary very often now, billionaire, millionaire. And at times I have asked students, you know what a billionaire is? How many zeros a billionaire has in his wealth? Then they're like, maybe 5, maybe 4. Billion means 9 zeros. So you have to multiply it by 9 zeros. So that concept needs to be there, because this is a language we are living with nowadays. Okay. So now in astronomy, we're going to be dealing with a lot of big numbers, very big numbers. It's hard to pronounce this big number in one go. So what we usually do, this is a standard notation of writing a number. We write the big numbers in scientific notation, where we introduce decimal point. So students need to be comfortable if they go from standard to scientific notation, what would be the power of 10 if they have a very big number? They also need to make sense if there is a very small number, size of a charged particle, and they rewrite it in scientific notation, there is a negative in the power of 10. So they need to understand if it's a small number, the power is negative. If it's a big number, power is positive here. So that correlation, they need to make sense, and so be comfortable to go back and forth. And then significant figures. How many digits are actually significant? Is 0 going to matter or no? All that concept becomes part of the mathematical skill building that we do from day one. So this is SmartWork assignment, one question, where one of the questions in the assignment is if student is comfortable to go from standard notation to write it himself or herself in a scientific notation. Now the second part is also equation. Can they make sense of 3 different images? How different they are in terms of mathematical analysis? Well, this is more elliptical, less elliptical, and this is circle. In mathematics, we call that term as eccentricity. And that's Kepler's law in astronomy. So circle has 0 eccentricity, and then we have a little bit more eccentricity of long, and then we have good eccentricity. So they need to make sense of that in order to understand solar system. Sun is in the center, and around goes the planets. This is that simulation I was talking about. So I give an opportunity to students to play, this is this is lunar phase simulator. If sunlight is coming this way, then if you play with this, your position, how moon is going to change. So they have to play the control buttons here and see if they can make sense of full moon, new moon, etc. Okay. Sometimes technology is a glitch. We are stuck. What do? Well, we go back to paper mode. We print out, and then we look at the same information. I wish it was more clear. It's the same thing what I was showing in simulation. Now we're trying to see in a paper where we're trying to see moon's phases when sunlight is focusing on the Earth here, and then moon going around it. So this way, A, B, C, D. This is moon going, sun, and this is Earth. So we go back to traditional way, and that's really important too. Students need to be comfortable to be able to use pen as well. That is not the replacement. That is to add into the advantage, but not a replacement. Then, since I'm not physically present in online class, we have lots of video by resource, not in publishers again, where an instructor is actually explaining the same thing. This is again the lunar thing we are trying to explain here. So ideal would be when I'm ready at a certain stage where I could create my own videos and post it. But right now we have a package ready, and that's what we're using. So this is another of my methodology to encourage writing among students, and that is also a skill area which needs a lot of attention for students. The grammar is off, the formatting is off, there's no citation. So all that we help students. When I say we, it's the faculty who are teaching astronomy, and I'm the astronomy coordinator, but we all do it together. So this is the news that was big news in 2017 in the September, where Cassini became the first spacecraft to finally orbit Saturn. And they heard about this news. They asked me, what is this about? I said, okay, why don't you research? Here is the question, explore it, what it is. Try to draft your writing in these steps. This is one orientation. If you want to be out of the box kind approach, then very welcome to do that. But this would give you some orientation. But make sure you cite it. And this is some of the examples. So we do work on some writing. It's not only click button, because that's what people think that, okay, if you're using online technology, we're just clicking. No, we're also doing the writing stuff. We're also discussing. Discussions haven't been that fruitful because students take time to build up the vocabulary of astronomy. They use very common language, and that's what I'm trying to help students to use scientific language. If they're talking about distance, they should say light years. They shouldn't say long, more distance, less distance. So we're trying our best here, but this is an area which can require further attention. Just picking up topics, something that could attract them, like twinkle, twinkle, little planet. Why don't we say that? Why do we only say twinkle, twinkle, little star? So that makes them think, and then they engage in discussion. And of course, I give them the guidelines. This is how much your post should be. You have to reply to 2 students. Use at least 3 new vocabulary words from your astronomy. Build up on your vocabulary, and at least cite one source from where you're picking up that information. So these were different tools. And one final one, we do watch movies too. I think that adds a good dimension to online learning. But we don't stop there, because at the end of it, students have to do some quiz. So that's good. So they're not just watching for the sake of watching, but they're trying to engage and extract that piece of information, knowledge from movies. This is all related to Martian movie, this quiz. And this has been very popular, of course. Okay, so these were different methodology steps that I mentioned to you. What is the key thing in online learning that I have learned in the last 3 years? Good organization of the material. Because when we bombard them with too much of information, we're no different than Google. They have all that information. We want to structure it in a way, week by week, so they feel motivated with just the right amount of information. And then they move on to next week, and then they build it up on their own. So the way they usually get it, besides the welcome, there's a weekly folder they get. Week 1, the date of the class, it's usually Thursdays for me. and we are at chapter 1. There are 2 folders in that. The link takes them to weekly assignments, and there are 2 folders. One folder is lecture notes, other folder is assignment submission. So they can distinguish. First they do the lectures, material, the resources, videos, dictionary, or PowerPoints, or Nebraska simulations, or Astro tours. That's all in the lectures, which I would have done in a regular class. And then the second one is assignment. What homework are they getting? Are they getting smart work homework? Are they getting writing assignment? Are they getting discussion? So they're tuned. By the end of semester, they're tuned. They're getting 2 folders, one to study, one to perform. And also, we use Blackboard to communicate with students at Bronx Community College. If there is any information that needs to be communicated, that goes by via Blackboard rather than SmartWork. So this is the SmartWork assignment that I was talking about. As you can see, this is giving me, this is a broad outlook of the SmartWork, where I can see how many students. Usually in an online class, I have max up to 20, and if somebody drops, then in this class it's showing 17 students in the class. How much time on an average a student took to complete the assignment, and what is the average class percentage. And the report would tell me individually, each student, how much time that student took, how much is the average score gained by that student in all these assignments. So this is what I see in a graphic way, the same information. I'm sorry, I think you can't see, but what it's trying to show here is graphically. This is the score percentage it's showing, and that over there is the number of students who completed the assignment and what is the average time everybody's spending. So I'm doing a lot of data analysis here. This is where most of the time students are spending.
Okay. We're running out of time. Yeah. So, thank you. Thank you so much for your presentation.